Shape for Skittles is approximately normal because when I do n times p, I get what? 10.8, which is greater than or equal to 10, so we're good. And when I do n times 1 minus p, we get what? 39.2, greater than or equal to 10. So Skittles is approximately normal. What's the mean for my Skittles? 0.216. It is the population proportion. What about the standard deviation? We've got our formula over here, p times 1 minus p over n, and then square root the whole thing. (0.0582). And I'll put this up on the screen here in just a moment. For the M&Ms, are we approximately normal? Yes. N times p gives us what? 10. Has to be greater than or equal to 10. It hits that or equal to mark. Excuse me. So we are approximately normal. What's the mean? 0.2. What about our standard deviation? What is our standard deviation? N times, sorry, not n times p. P times 1 minus p divided by n, square root the whole thing. Yep. Depending on how you round, 0.0566, 0.0565. I'm never that concerned about the very last digit. If you give me 4 decimal places and it's only that last one that's different, we're all good. So if I look down at number 6, describe the sampling distribution of the difference between the proportions of orange Skittles and orange M&Ms. So I'm going to do x minus y. How would we describe that shape? If Skittles is approximately normal and M&Ms is approximately normal, the difference is going to be approximately normal. The two populations that they're coming from are approximately normally distributed, or my sampling distributions, are approximately normally distributed. So the difference between those proportions will also be approximately normally distributed. How would I find the mean of the difference between those two proportions? How do I find the difference in the means of those two proportions? Subtract them. So 0.216 minus 0.2. Can I do the same thing with the standard deviations? Can I just subtract those? No. We have to use what? I can't use the standard deviation. I have to use the variance. How do I take a standard deviation and get a variance? Square it. And then do I subtract them? Will this actually make this narrower? No. I'm going to add them. I'm actually going to have more variation. So I want the variance of one, the variance of the other. So I have to square those standard deviations from the previous screen. Let me pop that back up. I have to square those standard deviations. I add them together, and then I square root it so that I can get my new standard deviation. I'll pop those answers up on the screen in just one moment. I do want to talk about number 7 before I pop up my answers. Mr. Wilcox and Mrs. Gallus calculated a difference between proportions of 0.08 from their samples. Calculate the probability of getting this difference in proportions or higher. We said that this was distributed how? How did we describe our shape? Approximately normal. So I'm going to use that to help me answer this question down here. It is approximately normal. Do I know my mean? Yes. What was the mean when you subtracted those? 0.016 for the mean. Do we have the standard deviation? 0.081. So this right here, 0.081. I took mine out one more decimal place. I got a 2 on the end. If you stopped at 3 decimal places, that's fine. So this is approximately normally distributed. 0.016 for our mean. 0.0812 for our standard deviation. And what's the value that we have to work with here? What did they find, Mr. Wilcox and Mrs. Gallus? They found this. Calculate the probability of getting this difference in proportions or higher. Well, 0.08 is going to be over here somewhere, right? Or higher means this way. I gave you a hint. I gave you this formula, but I want to look at each of these pieces. They found a difference in proportions of 0.08. I'm going to put that in for this piece right here. 0.08. Proportion 1 minus proportion 2. That's this right here. Do we have that value? That's the mean of my difference. So we have this number. So we're going to subtract those. What is this thing on the bottom? That's a lot. That's my standard deviation. Do we have that value? Yes, we do. That's this part right here. So we can calculate our z-score, or we can put this right into our calculator because we have our lower end. What would we put in for the upper bound? Something large, right? I could put in 1 because that'd be like 100%. And that's definitely way bigger than this is going to go. If I go out 3 standard deviations, that's way bigger than that. So I can do normal CDF. I can calculate z-score and do table A. Or I can do normal CDF. Lower bound of 0.08. Guys, it is really important to label what these numbers are inside the parentheses. One of the things that I noticed as I was looking at different final exams was we've got some big ideas, but we're missing those little pieces that would take us from a 2 to a 4 or from a 3 to a 4. So lower bound, 0.08. Upper bound, we could do 1. Very large in comparison. 0.016 is my mean. 0.0812 is my standard deviation, and then I can pop that into my calculator. What is that probability? That's something smaller than 0.5. Yep. I got about 0.2148 when I used table A. I didn't actually pop it in my calculator because I did table A, but yeah, about 0.215. What is this? If you go ahead and calculate the z-score, what does that tell me again? What is a z-score telling me? Does anybody remember? How many standard deviations we are away from the mean. So notice when I had my 3 standard deviations marked here, after I found my z-score, I was like, oh, that's not quite 1 standard deviation away, so I knew it shouldn't be way out over here on the tail. When you're doing a quick sketch, you need to know, is it to the left or to the right? Which way are you shading? They're not going to get, oh, is it 1 standard deviation or 2? But I do want you guys to make the connection that when we calculate a z-score, they're telling us how many standard deviations away we are from the mean. All right, important ideas here. Sampling distribution, shape, center, and variability. It's approximately normal if both of the sampling distributions that I pulled this from are approximately normal. So I'm going to use my large counts condition, or my law of large numbers, on both populations. My center, I just subtract the two proportions. For my variability, if I know the standard deviation of both of my original populations, I take the standard deviation, I square it so I have the variance, I add them together and I square root. If I have to calculate each of those standard deviations, that's what it's showing underneath that square root symbol, is how to calculate the standard deviation for each of those sampling distributions. Calculating this z-score, and I realized I kind of squeezed it in on the end. It's got all these different letters and all these operations going on. But what it's telling me to calculate that z-score is I'm going to take my observed difference in proportions. I'm going to subtract the mean difference in proportions. And I'm going to divide it by the standard deviation of the difference in the proportions. Once you guys are done copying this into your notes, I want you to take about 5 minutes and try the check your understanding at the bottom. If you're not quite sure how to do the check for understanding, look at what we did on number 6 and number 7 on the other page. If you're not quite sure how to do the check your understanding, look at number 6 and number 7 on the previous page. Try to finish up in about the next 4 minutes on the check your understanding, and then we'll go through those pieces together. What is our shape? Approximately normal. How do you know? Yes. We have passed law of large counts for our juniors and for our seniors. So both of the sampling distributions for those two populations are approximately normal, which means the difference is going to be approximately normal. What's our mean? Point what?
2.
Close. What was the proportion for my seniors? Super close. What's the proportion for my seniors? 0.65. What's the proportion for my juniors? 0.42. I subtract those two and get 0.23. Yep. Got it. And then we need to calculate and interpret our standard deviation of the sampling distribution. So you should have gotten 0.1253 for your standard deviation. The difference in sample proportions who have a parking pass typically varies by about 0.1253 from the true difference in proportions of 0.23. The difference in sample proportions who have a parking pass typically varies by my standard deviation from the true difference in proportions of 0.23. I'm going to leave that last part up on the screen. Does anybody need part A or part B up on the screen? Okay, I'll leave part A and part B up for another minute. All right, C is still up on the screen, so if you were copying that down, that one's still up there. What is the probability that the difference in sample proportions, senior minus junior, of students with parking passes is greater than 30%? We know this has what shape to it? Approximately normal. We know our mean, which is what? 0.23. We know our standard deviation, 0.1253. So how do I find the z-score for this? How would I find the z-score? 0.30, this is my observed, right? Minus what? 0.23 over 0.1253. That's what I would do to find my z-score. If I do that, I come up with a z-score of what? .55 or 0.56, depending on how you round that there. If you're using table A, you would only need to take it out to 2 decimal places. If you're going to use your calculator and your normal CDF, you don't have to worry about your z-score. But this does give me a rough ballpark in my mind about how much of that area is going to be shaded. So would I be expecting more or less than 50%? What'd you say, Parker? Less. I would expect less than 50% because I want 30% or greater. So I'm going to be over here to the right, about half a standard deviation over. So it's going to be less than 50%, but not super tiny. When I looked this up, I got about 28.77%. So again, less than 50%, but it's not that really, really tiny like 1%, 2% stuff that we've looked at before. Take a minute to get this jotted down into your notes. Once you have part D in your notes, I want you to have pages 14 and 15 open so you can see both of them at the same time in front of you. Pages 14 and 15 open side by side so you can see both of them. Looking at page 14, has a table like this. And down at the bottom, they have our summary statistics for us. These are, I don't remember what year this was, but these are the heights for power forwards in the NBA. We've got 115 power forwards in the NBA. And the heights of all of those different individuals here. What do you notice about that dot plot down at the bottom where they took everybody's height and they plotted it? How would you describe that to me? It looks approximately normal there. Is this for the whole population or is this just for a sample? This is my whole population right here. What is the mean of my whole population? 80. Point what?
0.87.
Tell me how you got more precise than just 80. Over here, the summary statistics, the table, it tells you the mean 80.087. We want to be as precise as possible for our population mean. That's absolutely correct. What's our standard deviation for our population? 1.519. Absolutely. Okay, so we're going to pull samples from this information here. On your phone, you're going to want to grab like a random number generator. If you just Google random number generator, there's a whole bunch of them that pop up. Google even has their own random number generator. I want you to pick out a sample of 5 numbers, anywhere from 1 to 115, so you can pick out 5 of these power forwards. And you want to write that on the first line. Let me pull this up so that I can demonstrate for you. Real quick before I write mine down. Our population is all the NBA power forwards. Sample is going to be 5. The 5 NBA power forwards that we selected. Our population distribution is approximately normal. We got the mean and the standard deviation off of those summary statistics from our whole population there. Back to this if you need me to, but I am going to scoot us forward one screen so I can demonstrate what I want you to do. So using my random number generator, the numbers that I got, the individuals that I selected had heights of 81. Second individual had a height of 82. The third individual had a height of 81. Fourth individual had a height of 80, and the fifth one in my sample had a height of 78. So I used my random number generator from 1 to 115, making sure not to repeat anybody, so maybe make a mark so you don't count the same person twice. And then after you pick out those 5 individuals using your random number generator, I want you to find the sample mean. So you're going to add and divide by 5. So for mine, I had 80.4. That's my sample mean. You're going to go through this whole process a grand total of 3 times. So you're going to use your random number generator, pick out 5 power forwards, record their heights, find the mean. Then you're going to pick up your random number generator again. You're going to pick out another sample of 5 power forwards. You're going to record their heights. You're going to find the mean. You want to make sure that you are selecting your sample randomly, which is why I asked you to grab a random number generator. Hopefully we can get this part done before the end of the class period. What I want you guys to do there we go. Once you have your 3 samples of 5 individuals. Once you've taken a sample, calculated the mean, taken a sample, calculated the mean, taken your last sample and calculated the mean, come up here and put a dot on the dot plot where it belongs. You should just be able to do a single dot for each of these.
If we get a decimal, should we like round down?
No, there should be decimals on there, so each of those are 0.2s.
Gotcha.
Good question. Each of those little tick marks up there is a 0.2, so it goes 0.2, 0.4, 0.6, 0.8, and then another whole number. Very nicely done. How would you describe the shape? How would you describe the shape? What do we think? Does it seem to have mostly a bell shape to it? So I don't think it's perfectly normal, but could we describe this as approximately normal? If we had even more people in the class, so we had more and more and more samples to add, would it take on more and more and more of an approximately normal shape the more samples we take?
Yeah.
Yes. So I would describe our shape as approximately normal. Oh, sorry, did not mean to zoom in like that. There we go. If I asked you to estimate the mean, where would we estimate our mean at? 80.4? Sounds good. Estimating that standard deviation. What do you think? If we said 80.4 ballpark was our mean, standard deviation to one side should capture about 30% of it, right? Let me see if I can draw in. All right, so there's my really bad normal curve. One standard deviation. See, about like this. If I come down, how far are we here? Looks like maybe about 0.4. We're just estimating. All right. Let's come here. I'm going to paste in what we have here. Use a normal distribution to find the probability of taking a random sample of 5 power forwards and getting a sample mean of less than 79 inches. So before we get into that, I want to make sure that we have the correct values to use here. This is approximately normal because the population distribution was approximately normal. What we saw on here with our dot plot. My population distribution was approximately normal, so my sampling distribution is going to be approximately normal. The mean of x bar is going to be the mean of my population. What was the mean of our population? 80.087. So this is what we're going to use instead of this. We did an estimate based on our graph, but this is what we're going to use as the mean. For the standard deviation of x bar, we're going to take the standard deviation of our population. We're going to divide it by the square root of our sample size. What was the standard deviation of our population? 1.519. We're going to divide that by the square root of, how many were you guys picking out each time? 5. .67. We're going to pick up here tomorrow. We'll answer question number 6 tomorrow, and then we'll do our big ideas. First homework is due tomorrow. For those of you that did not have me last semester, you'll be turning in your homework on Canvas. You need to turn that in as a PDF. If you are not sure how to do that, please come and see me. You will upload your homework on Canvas as a PDF. If you're not sure how to do that, please let me know.